Good afternoon. I thought it was going to be good morning, but the plane leaving Budapest wasn't super cooperative. So really excited that I was able to make it here and be with all of you and help close up the conference today. Now, as I had a lot of time sitting on planes today, I reflected a little bit on kind of an interesting metaphor for serverless. And you know, what I was thinking was, it kind of made me think, in a way, of the progression of programming languages from assembly language to the kind of modern things we do today with Node and Go and Python and others. Because once upon a time, with programming languages, you had to think about the machines. Every register name, the calling conventions, all of those aspects of the hardware and the infrastructure showed through in the programming model. And now, we just think about what we want to accomplish. We focus on the outcome instead. And I think there's a nice analogy there for cloud computing. Because infrastructure is a challenge to deal with. All of the provisioning and deployments that we're familiar with, and serverless helps us stop thinking about that level of the hardware and instead start focusing on a much more outcome-oriented solution. So, lots of things to talk about here today, lots of exciting, innovative themes we want to talk about. But before we get to the future, let's seek a little bit of context in the past, and maybe also talk a little bit about some of the nomenclature. Then I want to talk about the most important thing for all of us in the serverless movement, which is not the technology, not the vendors, but the customers. Because there's been so much amazing adoption that's happened in the last year, and I want to talk a little bit about how customers are discovering that innovation and experiencing the benefits of serverless, because it really is changing the way that they think about their business solutions. And that, more than anything else, is the most exciting thing that we're doing here. And then finally, I want to talk a little bit about how the serverless platform is maturing, not just at AWS, but across all of the vendors and this broad ecosystem as well. And it's converting from just a computing solution to a full-fledged architecture. So let's get started. So serverless computing lets you build and run applications without thinking about the servers. And we all know that there are still servers there running your code in the background, the same machines that have always been running them in the cloud. But I still think there are three really good reasons for this term. First of all, there's this concept that's really important, this theme of taking infrastructure complexity and kind of handing that over to, in this case, a cloud service provider. And whether that's the servers in compute and all the deployments and provisioning and capacity management, or whether it's disk drives and storage on an object store or a database system on a NoSQL database, whatever it is we're talking about, it's really useful to have a word for this powerful thematic of handing over that infrastructure complexity. Now, the second thing is that, at least for computing, it actually changes the software model, because you stop having to set up this fleet of machines and this software just to receive requests. And that really is an important change. It changes the way we think about the architecture, changes obviously the way companies have to write the architecture, but it has some of these amazing benefits, like making it much more simple to plug it into an event-driven system, make it much easier to hook up to existing event sources, and, of course, making it much easier to deliver this economic outcome, where you no longer have cold servers, cold machines, even cold containers to worry about. And then finally, there's a third one, which is a little bit nuanced, which is that you stop thinking about the edges of the servers. It's serverless not just in the sense of not having to sort of worry so much about the infrastructure, but to not have to think about the placement barriers of your deployment. And we're going to talk a little bit here about kind of this growing trend around big data and serverless big data. And that becomes really important, because the more and denser compute that we run on these systems, the more important it is that the systems feel like a continuous experience, because those placement operations are incredibly challenging to do. And that's one of the nicest things, and I would argue, probably looking forward, maybe one of the most important reasons to have this term. Okay. Now we're going to kind of take that little bit of a tour through the past year. So I'm going to do the modern history of computing in 3 slides. Let's see how that goes. So about 10 years ago, we've got physical servers in data centers, right? And the challenge of building large-scale software is primarily a hardware one, because you've got to get enough of those servers in place in order to get some work done. Then along comes virtualization. And virtualization is really important, right? Because it helps us be more efficient in our use of that infrastructure. But of course, the companies are still owning and managing the underlying hardware. And then the big turning point. We move those virtual servers to the cloud. And now suddenly, economies of scale appear, and this ability to provision massive amounts of capacity appear. But also, we start thinking about those machines differently. We're letting somebody else take care of them for us. Now, each of these steps provided something important. You know, that a virtualization one, for example, helped us think about better utilization, better hardware independence, and ultimately disaster recovery. And the cloud one, well, you've heard all the advantages there. Most of you are certainly experiencing them. The elasticity of the resources, the ability to provision things in minutes rather than weeks or months of time, as would have been typical once upon a time. And it also began this important process of shifting maintenance burden from the application owner over to a cloud service provider. But of course, even these cloud-based infrastructure solutions have limitations, because you still have to think about those virtual servers. You still have to administer them. You still have to worry about sizing the workloads. You obviously have to manage issues of fault tolerance and scale. And that scale is important because that capacity planning exercise is easy to get wrong. Too little, and you can't run the customer workload. A request comes in, you have no place to put it. Too much, and you're overpaying for your compute. And that can be really challenging if, for example, you're talking about a peak-to-average ratio of 10 or 100 or more, because now you have a massively over-provisioned system almost by design. So, kind of origin story for me and at AWS, about 4 years ago, I joined, and we asked ourselves this question of, how could we give customers that value of cloud infrastructure and all the things that are good about it without having to ask them to go manage and operate a fleet of servers? And one of the words that kept coming up in those conversations was simplicity. How do we get rid of that infrastructure burden? How do we help customers with not just the servers themselves, but also getting their applications to run on these fleets? And we're not having to think too much about how that deployment and management works. And so that brings us up to kind of where we are today with the serverless movement. With these approaches, those challenges of provisioning in servers, worrying about whether or not you're actually utilizing them or if something's sitting around cold, and all of those challenges of getting code onto the machines themselves disappears. Now, one of the nice things about the simplicity here is that we get a great one-to-many distribution. So the cloud service provider is in a position to think about really hard problems. For example, I'll draw kind of on our AWS one here. How do we design something like Lambda to minimize cross-availability zone calls? You know, that can be a real challenge, right? If you're trying to build your own architecture and have to think about a problem like that in each and every one of your architectures. But when we think about it, we get to solve it for a whole lot of people all at once. And that's huge leverage and a huge win. And one of the things that I think is really amazing about this too is not just is it simpler, but it can be faster, it can be more secure, it can actually be better in many ways. So let's talk about security as a good example, right? Well, for starters, no unpatched servers. You know, this is something that if you look industry-wide at all companies and ask how many servers out there that still have unmitigated challenges like, you know, dirty cow, for example. How many systems allow people to log in directly to those machines, to SH indirectly where maybe they shouldn't be able to do that? Running old versions of operating systems or inconsistent versions. One of the nice things about having your fleet managed this way in a serverless system is that we take care of that. So on Lambda, as an example, we cycle those machines multiple times a day to make sure that they're fresh. We apply security patches aggressively, and the entire fleet is kept homogeneous. Plus, every single call gets audited and authorized independently. Okay, so let's talk about another piece of nomenclature here, which is FAS versus serverless. So I want to talk a little bit about kind of how I kind of capitulate that. There are really these two spectrums of compute, if you will. The size of deployable unit, so everything from something as large as a virtual machine down to something as small as a function. And then another dimension of responsibility. So who cares for it? Is it you, the cloud service provider, or kind of a combination of both? And as an industry, we've given names to these different combinations here. For example, IaaS is a virtual machine that you manage. And of course, all the cloud service providers have offerings in these major areas. But I want to kind of focus on this right-hand side here, the function as a service side, where the unit of deployment is a function. And now what's interesting about this is that these functions still come in all shapes and sizes. So you can have a function that you're responsible for, you can have one that you share responsibility for, and of course you can have one that's totally somebody else's responsibility. And this is kind of how we view serverless. That serverless means no management burden. It means that the cloud service provider is taking care of that, whether that's scaling up or dealing with fault tolerance. And so if you've got systems where you're deploying functions, but you're still thinking about containers and virtual machines, we think of that as FAS, but not necessarily a pure serverless solution. Now, serverless compute itself is just one building block in what, for any vendor, has to be an entire platform of serverless offerings. Event sources, places to store state, and places to put storage in, streaming, all of this has to kind of be built together so that you can compose total and complete applications around it. And one of the interesting themes over the course of the last year, I would say, is for all of us fleshing out this portfolio so that customers can do all of the things that they want to do with their serverless apps, but also, and perhaps even more important, that those apps can sit comfortably in their existing architectures. So I'll take step functions as an example drawn from my own portfolio. Step functions on AWS let you run Lambda functions and other activities and coordinate them together. So basically it gives you temporal coordination. You can say run these functions in parallel, run them in serial, but perhaps even more important than the serverless part of that is that you can connect them to third parties. So maybe you've got a legacy system and you need to sort of wait for some information from it or an existing workflow, or you need to be able to retry because you're not sure how available all of the other parts of the application might be. And this is a really interesting theme because we start to see the serverless world getting some affordances to connect to things that maybe aren't always operating at the same level of scale or speed or something else. Super important because we know that companies are not going to be 100% serverless outside of perhaps some very small startups for a long period of time, right? We're going to coexist with all the existing ways of building applications. Now, one of the things that serverless kind of drives for all of us is this change in thinking about how developers get to deliver and the value that it can help bring to them in their companies. When we take away some of the heavy lifting, the need to build metrics gathering, logging, authorization, security, et cetera, into every single app, we free up a lot of the time that developers would otherwise be investing there. And that increased developer productivity allows them to take the parts of the business logic that actually matter, to focus on the solutions that the company's interested in. And of course, the companies that do that the best, and this is the part that's really interesting as we see companies discovering this for themselves, that serverless helps them innovate and compete better and faster. So, we talked a little bit about kind of history and nomenclature of serverless, how it fits into a broader landscape of serverless portfolios. Now let's take a look at developer community, use cases, and how some of those customers are seeing those benefits. So some of you probably saw this year, the Stack Overflow Dev Survey. I was very happy to see that serverless came in as a second most loved platform. The little hearts are mine there. So this was a really great day for me because it was a potent reminder of why we're in this in the first place, which is to make developers excited about writing their code and happy to let go of the parts of it that aren't exciting, that aren't fun, that aren't interestingly differentiated for them. And by the way, next year I want to be #1, so just saying. And over in GitHub, I just pulled some metrics here as we were putting the deck together, and we're seeing really interesting growth in all of the different vendors on all of the different platforms that are related to serverless. So lots of motion from both commercial and open source communities, both development and use. You know, and I picked some of the customers that we're currently seeing on AWS Lambda. I'm sure this is somewhat representative more broadly of this movement at large right now, that just a massive amount of adoption has occurred since we talked about this a year ago in New York. A huge range of companies doing just a huge range of use cases. And it's been really exciting to see that kind of adoption, and also to start this great feedback loop where we get fantastic experience and feedback and suggestions from companies who are solving real problems with this technology. And you know, it may not be so surprising to find some of the cutting-edge startups who are looking for ways that they can innovate and move faster. And I spent a lot of time talking to some of the venture capital firms about exactly that. But what's exciting here is to see enterprises, and not just any enterprise, but some of the most regulated industries in healthcare, financial sector, and so forth, who are really excited and have started adopting wholesale serverless practices. And we think that's amazing because that is often one of the places that's hardest to penetrate with new technologies. And so we're just incredibly excited to see how quickly the adoption of serverless is moving along. Now, I want to give you a couple of examples of that. FINRA is a really interesting one. They process 500 billion stock trade validations every day using Lambda. It's just an amazing amount of streaming data that goes through their system, where they can both store those in S3 and then use Lambda in combination with that. Hearst, as a digital media and publisher, has a huge number of properties in clickstream analytics, and it used to take them on the order of an hour or more to process that information every time a batch of it came in. And they've subsequently converted that into a real-time process, takes less than 2 minutes, incredibly much faster, gives them their business answers much, much faster, and for a fraction of what they used to pay for it. You know, I mentioned this kind of peak to average ratio problem. Vivo is a great example of that. They can handle 80x their kind of nominal traffic spikes, and they no longer have to hold on to all of the capacity and infrastructure that would have been required once upon a time. Expedia is doing over 1 billion Lambda requests every month for their traveler profiles, and they also use it as part of their code delivery pipeline, where they can do all of their code production and delivery now for in the order of $1 a month. And one of the major secondary mortgage market companies build a massively parallel Monte Carlo simulation system using just what is under the covers, a huge number of servers, but a large number of instances of Lambda functions to do these massively parallel algorithms. So it's really interesting to see this stuff become real and become meaningful in terms of what customers are able to accomplish with it. And what are those customers doing? Well, I mean, it's as rich and varied as the customers themselves, of course, but we see a few different categories here. Web applications being an obvious one where customers can go from little or no traffic overnight to massive sort of flash sales without having to think about the challenges of scaling up and scaling back down again. Other backends like IoT and mobile that are really easy to construct using serverless techniques. Media and log processing, where customers can drop things into, for example, an S3 bucket, then easily trigger some computation to take place on that, photos, documents, and so forth. And I will say that probably every major media type, you know, somewhere in the last 24 hours has been processed serverlessly at this point. I mean, it's really amazing to see just the variety of that, everything from photos to videos to bibliographic data. And then chatbots, I think, is really interesting too, because it's a great example of how this sort of webhook receiver style of architecture works really well for the same reasons that event processing works so well with serverless systems. And we're seeing that increasingly with Twilio, with Slack, with Facebook Messenger, that people are building these great bots to take advantage of things like Alexa or Lex for the natural language understanding, and then transition to Lambda functions to actually execute their logic and hook up to their back-end business systems. And it lets people who frankly know very, very little about working in the cloud get really interesting capabilities out of something like an Echo. I just picked a couple of customers here to sort of illustrate some of those use cases. Many of you are probably familiar with Square Enix and their gaming titles like Dragon Quest. And they use that media processing technique that I mentioned, where snapshots of kind of the game state or other images that their game players want to share get uploaded, processed, and converted into either thumbnails or copyright, watermark stamped, and then transmitted out from there. And they do 200 to 300 per minute on average, but they go up to 6,000 per minute when there's some kind of gaming competition going on. And they've been able to, at the same time, handle those spikes, but also reduce their processing time from hours to seconds. Thomson Reuters is a great example of a company doing streaming analytics. So every second, 4,000 requests come in as part of their product usage data and streams through a real-time pipeline they've built using a combination of Kinesis and Lambda. And what was interesting was not just what they built with it, but how quickly they built it in only 2.5 months and with only a handful of people. So for them, an amount of developer work that was so much smaller than what they would typically expect. Now let's come back to that other category and talk about big data and serverless. So I think these are two great tastes that go great together, and I'll tell you why. First of all, serverless systems let you spin up a whole lot of capacity exactly when you need it. And then, equally importantly, it all vanishes when you're done. And then there's the demographics. So lots of the big data practitioners are folks with job titles like research scientist or data scientist or business intelligence or business analyst. And they are never going to become DevOps specialists. Their goal is to get answers, not to do deployment and maintenance. And so for them, the more that we can open up and the easier we can make big data and the more problems we can make it applicable to through serverless techniques, the better. Now, one of the really nice things about working with big data serverlessly is that many of these kind of complicated big data processing frameworks, which frankly were mostly designed to harness and harvest infrastructure, just go away. So there's a lot less to learn in order to get started, and there's less to do in order to be productive. So for example, you can just with a for loop spin up hundreds or thousands of Lambda functions or the equivalent on other platforms, and then you can use that massive amount of parallelism at your fingertips to go off and do things. For example, to go, grab objects in a bucket and make some manipulation to them. In fact, mapping phases are even easier because you can simply wire up event responders so that as data files get dropped into something like S3, you can automatically process them. So you've got several of these interesting recipes that make it really easy to work with large amounts of data without having to actually figure out a complicated framework, and certainly without thinking about the infrastructure. And the money savings can also be pretty amazing here. So we just ran a simple little example where we did the big data benchmark. We used 775 million rows, processed it in a little under 5 minutes. But the interesting part was that the compute cost for that was less than a penny. And that's a really interesting price performance point to add to the big data sort of spectrum of options that are out there. And by the way, if you're interested in the framework that we use for this, it's in the slides, it's up on GitHub as well. It's kind of a simple combination of S3 and Lambda as a reference architecture. And it's not just the serverless community that started to figure this out. Pyron, which is a massive data framework that is built on top of Lambda, was actually done by Berkeley Amp Labs. It's an open source framework for doing essentially MapReduce in a serverless fashion. And in fact, its author was so excited about this, Eric Jonas, that he actually went off and wrote an academic paper on how serverless techniques can help people who want to do distributed computing, but don't necessarily want to learn how to do distributed computing, get answers. And his opening phrase there, if you can't read it, distributed computing remains inaccessible to a large number of users. And of course, then goes on to argue that serverless approaches are changing that. And in a nutshell, I think that's the promise of big data here, that we can open up and expand the power of the cloud and parallel processing and democratize that to so many other people. Now, vendors have an important role to play here. And vendors are going to distinguish themselves in part on how well they do this. So, of course, there will be innovative features, there will be the breadth of integration in the broader portfolios, but especially for things like big data, what's going to matter a lot is the ability to scale. So, for starters, it's got to really be serverless, because if step one is to go provision containers and machines, that's going to be challenging for lots of folks to get started on. But then you have to be able to do a couple of other things as well. For instance, the scale up, the first derivative, if you will, the velocity of increase is really important. How fast can you double, essentially, and then how fast can you continue to do that? So that companies who are bringing these large workloads can very quickly get up to the processing power that they need. And then a massive upper bound. That Monte Carlo simulation company that I was telling you about, for example, needs a very, very large amount of compute capacity. And so this is one of the things we need to be able to ensure that we can guarantee. And the economies of scale there make it plausible to be able to offer that to lots of customers simultaneously. And then a place where, frankly, there's a whole lot more for those of us who are vendors to do, flexible control. The ability to determine when you do have this kind of amazing amount of concurrency power, which functions get it and maybe which ones don't need it, so that customers can help us prioritize and control where that processing power is flowing among their different functions. And by the way, on the Lambda front, although we're happy to have customers always come and ask for additional concurrency, we've also been upping the default. So we doubled it to 200 this year, and then we doubled it again to 400, and last week we took it up to 600, and who knows where it will go from there. And the safety limit is really interesting because we want to make sure that customers who are trying out some of these big data solutions by default get a lot of processing power right off the bat without having to do anything special. And then if they decide they've got larger workloads, they can always get more as well. So serverless is quickly becoming this intrinsic core part of how developers think about modern and especially responsive applications. I think it's probably safe to say all of us are kind of equally well humbled and excited by the pace at which that is happening, how quickly enterprises and startups alike are adopting serverless solutions. Now, many of you were with us a year ago for that first serverless conference in Brooklyn. And in the year since, I would say really two of the most exciting changes that I've seen have been the introduction of great tools for creating and managing serverless apps and the growth of the ecosystem around it, a lot of which has been on display here over the course of the last couple of days. Now, helping customers succeed with a serverless architecture, it takes more than just a great compute solution, and certainly more than just a set of event sources to which you can attach. It's really an entire platform of capabilities. For example, you need deep support for security, great reliability, an integrated solution for orchestration, and a lot more. But I want to take a look at three of these: application modeling, developer ecosystems, and global scale, where a whole lot's been going on in the last year. Now, microservice is obviously a huge trend in our industry right now, and customers are increasingly using functions as a way to produce their microservices. And it's really a nice way to do it. I mean, first of all, as you think about breaking up a monolith, functions are a very natural way to express that computational capability. By their very nature, they're a really natural fit because they tend to be smaller, purpose-built, fit for purpose. And then on a serverless architecture, typically it's also stateless. So one of the kind of major tenets of a 12-factor app, it kind of comes built in. It becomes very hard not to think about it in that best practice fashion. But as more and more companies build more and more functions, what happens when you've got this entire app that's made up of lots of little pieces? So we get rid of the monolith, we think that's awesome, but how do we deal with the lots of little fragments that remain? How do we understand their relationship and manage them all together? So this is one of the reasons that we introduced Sam, who is both our awesome Squirrel Mascot, which you may have seen on the shirts, but also the serverless application model. And this is a standard model for representing serverless applications on AWS. So things like functions, APIs, event sources, data sources, the components of an app that logically go together can be described and represented in a SAM file. Now, it doesn't turn it back into a monolith. You can still change and deploy and understand those pieces in isolation, but it brings some organization consistency to the collection as well. And then, equally important, it simplifies the development and management of those apps. So if you saw Chris's talk, you've probably heard how we've integrated SAM into CloudFormation. That allows you to take this language for describing apps and use it in a tailor-made fashion to do things like deploy them out and create the actual resources in them. We've also made this an open spec because the goal here is not just to make our own products better. We want to make a larger ecosystem that can work together. We think that this ability for lots and lots of people to participate in a common description of those parts is going to be one of the key enablers. We talked about that a little bit last year. We spent a lot of time and energy investing in it, and we continue to think this is one of the key trends for serverless as a whole. And by the way, based on your feedback, many of you who've used early versions of this, we've also done things like adding support for inline Swagger, intrinsic functions, and function references. So I've tried to make this and continue to make this even easier to use. Now, one of the questions that maybe you've heard, certainly one that I get quite a bit, is, gee, but like, isn't a monolith easier to manage? I mean, it's kind of all together in one big piece. And you always like turn to the person asking and saying, well, I mean, do you put all your emails in one big file? Like, it's not the case that simply aggregating the pieces together makes it easier to do. But I will say that with small single-purpose functions and with the increase in the number of them, two interesting things are possible. First of all, you get a lot of metadata around the edges of those pieces. The system knows a lot about the individual functions and APIs and how they're related to one another. And we'll talk about this a little bit in a few slides here with Xray, but it lets the system help you out a lot more than if it's just basically a large code blob that's unintelligible to the cloud service provider. Because in that case, you're kind of on your own for managing and maintaining it. And also, I would say indexing and searching is a little more of a solved problem. For example, we launched tagging last week for Lambda, so you can now describe which functions go together, organizing them into hierarchies and so forth. All right, so one last kind of nomenclatural piece of discussion here. DevOps, like, is there DevOps for what's serverless DevOps? Well, I'll tell you what I think. I think that DevOps comes in two flavors. So with a conventional server-based approach, you've really got two categories of challenges. You've got the code, and your code needs an application lifecycle, the authoring and packaging, building, deploying, maintenance. But there's also this shadow problem of managing the fleet. Do the right machines run in the right places with the right copies of the code hooked up in the right ways? Have you deployed enough capacity? Are you monitoring every server? Do you health check it both before and during, and on and on and on? And I would say the interesting thing about serverless is that while all of the code challenges of DevOps stay, and let me be certainly one to say that we are nowhere near done with building out all of the pieces of code-related DevOps for serverless, including things like traffic shaping. Lots of work to do there still. But the fleet management portion goes away, and that part is a huge value add to people who are trying to deploy code without necessarily wanting to get kind of their all of their gold stars in fleet management at the same time. Now, one of the big challenges here, has been getting enough tools around things like CI and CD. And here's where things like SAM and other kinds of techniques, along with platform investments, become super important. So the ability to do things like commit your code, automatically have that pulled into a pipeline, be able to build it and package it, things like NPM and pip in the cloud, which are really nice for serverless apps. Being able to test it, including in an environment that matches the build environment, and of course, deploy it out. And so we've spent a whole lot of time and energy over the course of the last year trying to put pieces in place for this. And I know other vendors are doing similar things, and third parties are certainly working on these investments as well. Still a lot more to go, but the tooling area has been one that's been really exciting to see the rich set of investments. And last week, if you caught it, AWS also released Codestar, which is basically a team mechanism for building your code and allows you to kind of get both the deployment pipeline set up very quickly, bring your team members on in a really simple and easy way. And one of the parts that I love is you can get started in a really easy fashion. So like with a couple of clicks, you can say, hey, I want to build a fully working Node.js serverless web app, and boom, you kind of get all the pieces of that set up, including the full CI/CD pipeline, so that you can go make changes in a repeatable fashion. So that's really nice, because especially for folks who are coming to serverless, who maybe don't have all of the expertise and background on the DevOps and deployment side, it's really great to be able to give them some of the best practices in a more structured fashion to help them get started. Now, even with those mechanisms and investments in making it easier to build and deploy the code, what happens after you get it out there? So how do you debug these distributed applications now that they're composed of lots of functions and lots of services? And how do you gain insights maybe when something isn't performing or running the way you would like it to? So this is one of the reasons that we developed Xray. So Xray lets you see inside the application by providing tracing capabilities. And these include things like timing and retry, the ability to draw dynamic views of the sort of the as-built for your system. How does it actually work in practice? And then also give you things like timing breakdowns so that you can really get transparent insight into where the time is getting spent. And the way this works is that you identify which services, which front doors you want to trace and what percentage you want to trace. The actual Xray service is going to aggregate and essentially do the distributed join across those traces, drawing from all the different pieces of them. And then it'll give you things like the service map and the breakdown and the issue and root cause analysis parts of it. And this is the kind of thing that we all need to be thinking about from lots of different perspectives, both vendors and third parties, in order to help people put Humpty Dumpty back together again, to understand how all of the different atoms relate now that they've broken their code up into these serverless fragments. So I'll give you a quick example of where this could add some value. Here's a little S3 event responder in Lambda, 2 lines of code. Surely has to work. What could go wrong with a couple of lines of code? So if I fire this up under Xray, I can see my call being made to Lambda, Lambda firing up the function, and then the function calling S3, but S3 returned a 400. So I've got a 4XX there, which is why it got colored in orange. So, gee, like something went wrong there in those 2 lines of code. So we could flip over and take a look at kind of where the time is getting spent, but I want to actually focus on the error here. And so I could click on that and say, remote fault caused by no such bucket. So the bucket didn't exist. Turns out I misspelled bucket in the code here. So I could go fix this, I could run this again, turns green. And this is a quick and easy example. Of course, in a much more complicated example, we might have dozens of these different services and long chains of call patterns between them, synchronous, asynchronous, back and forth. And that's the kind of problem we're going to have to help developers solve and understand as they think about their architectures in this new and much more granular pattern. All right, so as excited as we are by all these improvements to developing and diagnosing serverless apps, we're even more excited by what is happening around them, the rich and growing ecosystem, and all the amazing things that a lot of you are dreaming up and delivering them. And last year, those of you who were there might remember I issued a call to action saying, help us create a serverless ecosystem. And it's amazing to see what's happened. I mean, in the course of the year since, so many different companies, and I'm sure I have only a fraction up here on this slide, have been doing incredible things with Lambda and other serverless vendors. And to just pick one particular category of serverless web apps, there are now offerings in both open source and built with commercial partners who have basically provided solutions for every possible language. So Express on Node and Flask for Python and Java and C#. So it's really exciting to see all of the investment that's gone on here, but also at a kind of a meta level, how we're now helping developers who have prior knowledge, information maybe about and expertise with things like Express, become more quickly productive on serverless systems. And I think that's kind of a key trend line here as well, reusing and repurposing that existing developer knowledge. So we talked a lot about scaling up so far in this presentation. Let's talk now a little bit about scaling out. So bringing compute closer to the end user. So FAS is really good at extracting code from machine boundaries. Where else could we take functions? And we're really excited about this question because we think that the cloud isn't the end, it's just the beginning. So AWS Greengrass, something we launched last year at reInvent, extends Lambda functions to devices. Low latency, near real-time, message-driven responsiveness, where you can take the same mechanism that you, for example, use to write a Python Lambda function in the cloud and run it locally on a device, even if the device is detached from the internet at the time. And we think we're going to see that in lots of exciting places, but one that is already out there is the snowball. So we realized that when customers get snowballs in order to transfer data and some of their storage needs from on-prem to the cloud and back again, that often that storage didn't happen in isolation. Often they wanted to do compute with it, maybe compress or audit or do other kinds of transforms along the way. And so by adding Greengate to Snowball, now they can run these Lambda functions directly on that device, even if the device isn't hooked up to the internet. And this is a really interesting example now of functions starting to make their way out of the data center and into a lot of new places. And between devices sort of all the way out on the edge, like IoT, and the data center itself, are these points of presence. And we've also added Lambda functions to those. So we've enhanced the CDN functionality of CloudFront, for example, by being able to process events when a view request comes in, when that request goes back to the origin, or on its way back out again with the response. And so you can do really interesting things with this now. You can start to think about customizing responses depending on what the client is. Maybe mobile devices in France get a different experience than tablet users in the US, for example. You can do things like validate your visitors, handle bots differently from your human visitors. And things like A/B testing, where maybe you want to send some of your traffic to one version of your website versus another. And we think this richness of compute and the capabilities that you get with serverless are going to start to flow out into more and more of these places over time. I think this is a really interesting trend line. And that trend line, writ large, is really amazing because that abstracted power of serverless that works really well for data centers, turns out it can be applied to these small devices as well, where you have a whole lot of them. And there's kind of a law of constant silicon there, right? You know, the more devices you get, kind of the smaller they tend to be. And the cool thing is that functions really work everywhere in that continuum. So I want to recapitulate some of the trends we're seeing here. Lots of adoption, probably one of the most important ones, since, of course, for many of this is not just an interesting technology, but a business. And probably most interestingly, lots of enterprise adoption. More complete sets of tools and features, even though we know that there's more work to do on that one. A really exciting growing ecosystem, and maybe even more importantly, lots of bridges getting built to existing frameworks, existing developers, and existing patterns. Broader and deeper integration with other services, both first party and third party, and in lots of different dimensions, temporally, spatially, event sources. Denser compute and much higher scale. And there's kind of been a progression here, right, of people who said, hey, you know, serverless is a great way to kind of like hook up some small things to, serverless is a great way to process, you know, maybe some of my analytics pipelines to, wow, I can actually use this for the most complicated, highly parallelized programs that are in front of me. And that big data piece of this, we think, is probably one of the most exciting and interesting ones of all, because it drives so much of what our industry is ultimately about. And finally, this sort of ubiquity of functions, this idea that the computing paradigm that we've sort of latched onto here is an exciting one that we can put in lots and lots of different places. So our little serverless thing has sort of grown up. The completeness of the architectures, the number of the developers, the choices available to customers, all of them continue to grow, and grow at an amazing pace. We're probably twice the size of what we were at last year's Serverless conference, and I think next year we're going to need a much larger venue again. And all of you are at the forefront of what's been called the most exciting and innovative change in computing. I can't imagine a more exciting journey to be on together. And so that brings me to the end of the talk here. Unless, of course, you'd like to see something else. So some of you may know that we have this sort of tradition of trying to get rid of servers. And so last year there was the baseball bat incident, and in Tokyo there was this thing with a sword. In Vegas last year, we had a magician come up on stage and made some servers disappear. But this time I thought we should think outside the box. Or actually, we should think inside the box. Alrighty. So we got a nice, powerful blender, and I think we do a little memory, and we do some CPU, and we do a piece of a disk drive. And then we take it to 11. And no, I'm not going to drink that one. Thank you all. Thank you all so much for your forbearance with my ever-changing schedule, and above all, keep Austin serverless. Thank you.